is that we have to have the cross-section lines in a cross-section. Remember, the whole purpose of these lines is representing that's where the part is solid. So if you're going to show me a cross-section and the cross-section doesn't have any hatching, then how do I know I'm cutting through material? Again, remember I used that example of cutting a stick of butter in half with a butter knife. If you look at the edge, you can see the little wavy lines where the edges of the butter knife cuts through. Okay, so I have my version of the trip finger also without a title block, without dimensions. Now, if we look at the two and say, hey, this looks much better than it did when we started, okay, because now we have a front view where we replace the front view with a section view, and we know it's a section view because it is labeled section view. If we don't label it, how do we know what we're looking at? We can't assume anything. Remember that you assume, you make an ass out of you and me, and that's how you spell assume. So remember that we have to have it labeled. We have to have our cutting plane line that shows you what are we cutting in half. I had several people turn in this drawing and they didn't have any cutting plane line and they drew a cross section. Well, all right, you drew a cross section of what? And just because you have it sectioned, if I do this, now I look at this and say, what am I cross sectioning? Because technically, this could be this. Okay, and you can see where my cutting plane line is now not down the center, so that would actually change this drawing, but I have no way of knowing where you cut the part without that cutting plane line. So it's very important that we first label, where am I going to cut? So I know that what am I going to draw? And remember that my hatches represent where material exists and where material doesn't exist. So as I look inside the trip finger here, I've got this edge, and this is a rounded edge. So if I look right up here up top, I've still got that circular wall that comes up to here where that part is coming through. So there's lots of little tricky things that we've got to take a look at. Does everybody understand what we're talking about when we're talking about sections so far? Okay, so the easiest thing to do when drawing a section view is to draw the whole through the orthographic projection, your top, front, and right side. Draw them as you would a normal drawing. And then when you get ready for your section views, then you can go back and omit your hidden lines. Okay, and say, okay, there's a hidden line. I'm going to turn that into a solid line. Here's my hatch. So now we're turning those hidden lines into visible lines. Now, one of the other drawings that we worked on yesterday was the holes drawing. And I saw an unbelievable amount of not good drawings with the holes drawing. You know, and all we were simply doing is just drawing the top view and the front view where the front view is shown as a section view. But how would we know that it's a section view? What do we need to have? And if you looked at your drawings that I've already graded, you would say, oh yeah, I didn't label the section view. And then I would say to you that all holes have
Center marks.
Center marks in all views. So many of you drew the holes in the front view. You drew the hole, and the front view was supposed to be a full section. And you drew the holes in the top view, but you put no center marks. You put no center marks in the front view, and then half of you didn't put hatch marks in the front view. Okay, so just a quick review. Remember that when I want to hatch, I'm going to go to the hatching symbol, and then all I have to do is select inside, and AutoCAD is going to select for me, as long as I agree to it, where my hatches are going to be. Okay, and then this, I'm using this person's original drawing, and we never go by block, we always go by layer, right, so that we can change it. So I can go back and change this and change that to layer hatch so it stays on the right layer. Okay, obviously we're not hatching that, but we want to make sure that everything is by layer, not by block. Okay, there's an exception on a few items, but not all. Anyone having questions on the section views? Your final exam will have a cross section. You'll have to draw a cross section in the front view. So in the section view, you have to have a cutting plane line that shows where am I cutting? Okay, what is the imaginary cutting surface that's going to cut this in half? If you can think of a guillotine in the Middle Ages coming down and cutting a watermelon in half, where is that slice going to happen? I need to see where it's going to happen. Okay, and then you've got to show me where is the material. Where am I cutting through material? There's no cross section here because this represents this back half of the circle, right? Where I see it as an edge or a surface. I see it as an edge here. So there's no hatching. So the hatching that I see here is from this point to this point. So simple things that we've got to take care of. And I'll tell you that the final exam is a lot more difficult than this one when it comes to the cross-section pieces. The final exam is not difficult, okay, but the cross-section portion is. We are taking a look today at week 14. Oops, where's my... So in week 14, it is open in on Blackboard already, week 14, day 1. Okay, and we are looking at a half section. So here is the half section. This is a tutorial. Now, as we look at the half section, we can see that this is what we call a union. Okay, so this line, these all represent the same surface. This line here is going to represent those interior circles. This line is going to represent the small hole that goes through the back side. Okay? And then obviously we've got this line right here that represents this box here. And these lines go out too far, but it's just a box. So we have this surface is here. This surface is this box. This surface is this box. We see this whole edge here as an edge. So the front top edge, the front edge. Okay, does that make sense what we're looking at right now? Okay, so we are doing a half section. So remember from last week, we talked that a half section is when we are only going to see half of the part. Now the thing about this drawing is you don't have to draw anything. It's already done for you. Okay, so what I'm going to do is I'm just going to draw a line here. And I'm going to copy the top view. And then I'm going to rotate the top view. Now, because this is a circle, would you not agree that we are taking this top piece and then we are rotating it around? So it's really the same thing on the side. So here we're showing it as a front view, top view. Here we're looking at it as a front view, right side view. So I'm going to get rid of that line and we'll use that for the lineup. Now it says, if we look at the cross section, it's saying we are looking at section AA. Okay, section, oh, and notice it's already labeled for us. Okay, that was already on the drawing. We just moved over the view. So far, what have we done? We've copied and we rotated. Now what we have to do is we have to take lines that are visible and make them invisible. So my cutting plane line says I'm going to come right to the center, to the middle of the circle, down and out. Okay, so I'm just going to draw a line, and I'm going to switch lines, say layers here, and I'm going to go to object, and I'm going to say there's going to be a line that's going to go from there to there. Now I drew my line, and I made my line longer than it needed to be. Okay, because we said that we were going to eliminate hidden lines, right? So we're not going to be able to see any hidden lines in the top view. So I'm going to delete, oops, wrong D. I'm going to delete some hidden lines that I'm not going to see in the front view or the right side view, because I'm omitting all hidden views. And I'm going to trim this hidden line because on the bottom half, this is all going to be revealed to me. So I'm going to trim because I know I'm not going to see the outside edge of the oh, that's a little funny. There we go. And I'm going to turn these lines into visible lines. Make sure that those are by layer. And now I have to hatch it. Okay, so I want to see what it looks like on the inside. So now when I go to my layer hatch and I hatch the object, that's all that I'm going to hatch. Oops, I got to trim this back a little bit. Because my cutting edge is saying, where am I cutting? So I have material that's here, right? So all I did was take this little piece of the pie and omitted it. So all I really did was this. And said, there, now what do you see when you flip it sideways? Does that make sense? So we're just rotating that thing. I'm grabbing it and I'm rotating it to the right side. And we're saying, what am I going to see if I remove that material? And this is all I'm going to see because I've cut it all away. I'm going to put that back. Oops. Now if I zoom out a bit here, I can see that what I have here is still the same surface that I have inside where it's hidden. Out here, I can see it as visible. And remember, the whole purpose behind section views are to remove hidden lines. We have no hidden lines in section views. So I'm just seeing the outside edges of the union. So my surface here represents my surface here. This little smaller block represents half of this edge. So now I'm only seeing that inside. So that's how, go ahead.
Would you have to hatch the outside, like the top part of it as well? Because that's technically solid material.
But I didn't cut through it.
Okay.
Okay. We only hatch where we're cutting.
Okay.
Okay. So, you know, I mean, we can't see it here. Yeah. If I was, you know, looking up, if I'm right here in this area looking up, then there should be a hatch. But based on my, you know, we can only look in one direction. We're not lizards. We can't look in two directions. So my arrow says section AA is only looking to the left. So when I rotate to the right side view, I'm looking straight at that part. This is what I'm going to see. This is where the saw blade, you can see where the saw blade is cutting through the material.
Okay.
In the top view, we're just saying, hey, we know something's going on the inside. We don't necessarily understand, But when we see the cross section, we can say, hey, there's a lot more material going on right here in the center than there is in the middle.
Okay.
Does that make sense?
Mhm.
Okay. Next, we're looking at our offset section. Okay, as I said earlier, we have to know what is it that we're looking at. So we have our cutting plane line clearly represented, so I can see where I'm cutting. In the front view, it's going to look like it's flat. I'm not going to worry about the little staggered edges. I'm going to draw this like it is flat. Now, one of the big problems that a lot of people have is as they look at this, like, which one of these is which? Is this a counterbore or is this a countersink? Is this a counterbore or is this a countersink? I don't know. I don't have the answer. I can figure out that answer by using the information. I can see that as I start to draw this, I can go, how is that going to work? Okay, so I do need to have some notes. And where are my notes? Not on. So one of them is going to be a countersink. One of them is going to be a counterbore, or both of them are counterbore. But we show one is a counterbore at a 1/4 inch deep, and one is a countersunk hole. So it doesn't say which one is which. If it doesn't say, then you can make the difference, right? But as you're looking at this, if I'm looking at this, which one looks more like a countersunk from the top? Is it the upper left-hand corner or the lower right that looks more like a countersunk hole?
Lower right.
You think the lower right looks more like a countersunk or a counterbore?
Countersink. Wait, no, counterbore.
Counterbore. The one up top looks more like a countersink because it's got a bigger head with a smaller shaft. Where the counterbore looks like it has a bigger shaft with a recess in it. So what we're going to do is we're going to draw that in. We don't have to be anything crazier than just using the geometry that exists. We know our depth's a 1/4 inch. Oops. So there's my counterbore, right? I got to get it in the right layer here. I got to get into my hidden layer. Right, so it's hidden. Now here's the thing. Do I need to redraw this in my right side view? It's got to be there, but do I need to? The question is it going to be on this line we'll call line number 1, or is it going to be on line number 2?
2.
Line number 1. So all I really have to do is just go copy. Now I notice I have a problem here with my drawing. And at some point it shifted. And I don't know when it shifted. So that's something you're going to have to fix too. And then when I draw my countersunk hole, it's going to be the same thing, right? line from my quadrant. I also know that that's offset by a 1/4 inch. Oops. I went over to the other screen, didn't click. Here we go. And of course, those are hidden lines, the layer hidden. Simply copy these. Over, right? All right, so that's how I was drawing my holes. That was pretty simple. So now we have to look at, we are actually cutting through, this is a rib. And as it says, note that we are not cutting through the rib. We're not gonna show that we just made a cut through the rib. So we're gonna pretend that this rib and this rib don't exist for the purpose of our drawing. But we know we also have a hole that's coming down to the top. That's gotta come down through. And it says add a 1/4 by 45-degree chamfer to the large hole and the top of the boss. Okay. Well, by creating to the top of the boss, we're going to omit that. We're not going to do that based on this drawing. But we can do the 1/2 inch or the 1/8 inch by 45, right? So if we just offset that by an 1/8 inch, and we draw a line, oops. Draw a line, tab, at 45 degrees. I'm just using my mirror command. Oops, didn't mean to do that. Now I have that boss again. These would be hidden, right? So if I was drawing the front view, that's the way it would look. We are not going to add the boss around the top. Okay, I want to say that again. We are not going to add it messes up when we're talking about that but we can do it. You just have to go around it. So we're just not going to do it at all. But we're going to create a hatch. So we want to see what it's going to look like. So remember, we're cutting through the center of this hole. So we're going to see this hole as it is. We're going to see the center because we're cutting through. We're going to see this as it really is. And we're going to cut to this bottom hole. So if I go to hatch, what am I going to see? And the problem is I've got an open line somewhere. And the reason I say that is because I should, there we go. I'm just making sure that all my lines, because somewhere it's open and it wants to jump. So I should be able to hatch now. There we go. So one of those lines, and I don't know which one, was just kind of short. So it was allowed to go through. But now that all of these lines, because they're hidden, they're not hidden anymore. Now they become visible lines. So now they become lines that I can see and not lines that are hidden. Okay, so that's our offset section. So remember the three most common types of sections we said that we would see. First was the full section where we cut the object in half. The second one was our half section where we're just going to cut out half of it. Actually, it's considered a quarter, but we're only cutting half of the object. We can't cut the whole object and still see, obviously, unless we did a full section of this guy. And then we have our offset section where we are going to jog through to see multiple different surfaces. But when we do an offset section, if we were drawing this in SolidWorks, SolidWorks would also make us put a line. SolidWorks would do this to show us that there's a cut edge. Does that make sense? But we don't. So in a 3D modeling software, it will sometimes do that because it knows that becomes an edge. But for traditional drafting, we omit that. We don't show it. So this is what our offset section is going to look like. But in review, we have our cutting plane line, so we know where we're cutting. We have our section view, so we can see what it's sectioned. Now I can go through and put those dimensions. So if I'm looking at this 1/4 inch deep, yeah, I could throw those notes up here like I did before. But now I can also, because they are visible, I can now throw a dimension on there. I'm not saying that this is the best way to do this. I mean, it's not how I would do it. But if I needed to, I could throw a dimension on that because it's now not hidden. It is now visible because of the section view, where before I put the hatches, it was an invisible line that I can't see. So we're telling someone who's looking at it, hey, if you were to cut this in half, here are the dimensions you're going to see. Does that make sense to everyone? Okay, does anybody else have any questions on cross sections or any type of sections, cross sections that we're working on? Okay, there is one more thing that I need to show you that I didn't show you before. I gotta find it here. Okay, what we're looking at here, this is a tap drill hole. This will be on the final exam. So if I was going to have, and I'm going to stick with that 1/4 20 that we did last week when we talked about a 1/4 20, 1/4 28 bolt. Remember that? So I'm in the machine shop, and I am going to drill and tap a hole to fit that 1/4 20 bolt. I know that my tap is going to be a 1/4 20. So looking at my chart here, I know that here's my 1/4 20. So my 1/4 20, as I follow that across, let me do a better job of Oh, terrible. There we go. So there's my 1/4 20 bolt. So I know, or I'm sorry, my tap. So I know the tap size, my tap size that I am going to use is going to be a 1/4 20. There we go. So I'm looking at my 1/4 20. I know that I need to drill a hole. If I drilled a hole that was a 1/4 inch, would I have anything to tap? Now look at my quarter. Here's my 1/4 20. Notice that a 1/4 inch hole is clear down here. So a 1/4 inch hole is much bigger than what I'm going to use for 1/4 20. So the drill size, the tap drill, the drill that I'm going to use to make the first hole, in this case, is going to be a number 7. So if I were to ask you the question that says, for a 1/4 20 tap, what would the tap drill size be? You would look at the chart, and okay, 1/4 20, there it is, has to be a number 7. If I said to you, I would like to use a 3/8 24. I want a 3/8 24 tapped hole. What size tap drill, not tap, but tap drill do I use? So I'm going to, okay, so here's a 3/8 24. Looking over and says, oh, that's a size Q. Now, size Q means absolutely nothing to me. So if you say that's a size Q, I don't know what size that is, okay? But the drills for a machinist will have them, and they are punched on the side, and it'll say Q. Now, if you don't know what size the size Q is, we have the decimal equivalent that it's 0.3320. I could use a mic or a micrometer or a caliper, and I could measure the drill bit and say, oh, that's the correct size. But if I'm telling a machinist, hey, I need a 3/8 24 hole, use a size Q tap drill to make that hole. Most machinists, when you start rattling off these sizes, they already know. I mean, they have it engraved in their head, this is what you use. I do not, by the way. I don't have any of those labeled for myself. Now, something we also want to notice, so we talked about a 1/4 and a 1/4 28. Two different, remember the 1/4 was a coarse thread, and the 1/4 28 was a fine thread. So the difference between the two is that a fine thread has a lot more material left in the hole to hold on to, so the hole can be slightly bigger. So a 1/4 20 uses a number 7, and the decimal equivalent of that hole is 0.2010. And a 1/4 28 is slightly bigger, so it's a 0.2130, and that's a number 3 size tap drill size for the tap to make a 1/4 28. Same size diameter bolt, 2 different size holes. Okay, important to know that. Okay.
Now, what's up with everything in between, like the 1/4 20 to the 1/4 28?
Okay. Well, in standard, we go to 1/4 28. The next size bolt up to 5/16.
Right.
Okay. So these are all standard sizes. So there's not a 15/64 drilled hole. Now, these are all different size drill bits that go through. Okay, so there's a size 2, size 1, size A. Now, with the class of fit that we're going to have, remember we talked about the class of fit, class 1, class 2, and class 3. Those will change the type of tap drill that you're going to use. So this chart is for a number 2, just a standard number 2 accuracy hole. So the fit's going to be a class 2.
Okay.
So these are all our standard size holes that we're going to go through. Notice as we get up in here to 1/2, 9/16, 5/8, we start getting more. You start getting down to a 1/4. Now we're starting to get pretty small. Now, do they make some really fine threads for like watches and stuff? Yeah, but that's on a whole nother chart. So this is just a generic chart. We're going to deal with mainly most things are going to start with a 1/4 inch and go larger. Okay, so now notice that there's also metric. And metric is a little bit different. Remember that the M for metric is telling us that it's metric. The 1.6 tells us that that's the major diameter, 1.6 millimeters. Okay, and then the 0.35 is the pitch. What's the pitch between threads? So 0.35 millimeters per point between. So we can see that they also have metric. So let's say that we were going to go with the metric number 10, 1.5. What tap drill hole we use, we'd come over and say, oh, that's an 8.5. And then there is the decimal equivalent, 0.3346. So let's say that you don't have a metric drill set. Okay, so I need 3346. So now we can jump over here going 334, 334. Boy, I could use a Q and go 332 and maybe get that same thing. Does that make sense? Now, typically, if you're doing metric, you typically have a metric set, but you can be interchangeable with your decimals if you can measure those. Does everybody understand how to use the drill tap? So this will be on the final exam. You will be asked what size tap drill, not tap. Remember, the tap makes the thread. The tap drill puts the first hole so that we can cut the threads. You're going to be asked what size tap drill, and we're looking at the drill size, is going to be used to make and then I will give you the thread size for that. So you're just going to have to use this chart, look on it and say, oh, so the only thing I'm asking you to do is to be able to read a chart. Does everybody think they can handle that? Okay. All right, so moving back into day 14, we have the two drawings that we're looking at. As far exam review, remember that we started out drawing all of our information in 2D, so using orthographic projection. And before that, I'm going to take you off sharing the screen here. Remember that we started off with how do we draw a line? And we said, okay, we can draw a line by using the polar coordinate system. We said that we could use the absolute system. Remember absolute, we said was like GPS, X, comma, Y. Then there was the relative, where we went at X, comma, Y. So from the last point, how far am I going to move over? And then we used the polar, where we went at a distance less than an angle. So then we could tell how to draw. So we started out with that system. And then we said, oh yeah, hey, there's that dynamic input that allows us to make drawings so much easier and have the heads-up display so that we could draw using that method. Then we started talking about dimensions, making sure that we dimensioned from smallest to largest, making sure that we could see dimension things in their where is it, so location, where is it, how big is it, and if it's a hole, how deep is it going to go, right? And then we, after dimensioning, we started to get into more orthographic projection from the front view to the right side view to the top view, and everything needed to line up, and everything we've done since then has followed that same system with the orthographic projection, even like the cross sections that we did today. So we're still using that same system. Then we started talking about cross sections and what's the different types of cross sections. So really, you need to know that there's a full section, a half section, an offset section, a revolve section, and just what are those. And the PowerPoint from week 13 steps you through so you can look and see what those are, as opposed to me reading those PowerPoints to you. And then we talked a little bit about threads and fasteners. There's not a whole lot, but I will tell you that, like I said last week, on the test, it will have a list of what does a quarter, 20, UNC, what does all that mean? So remember, we said that the quarter was going to be the major diameter. The 20 was going to be the threads per inch. The UNC was going to be the Unified National Course, known as the thread form. And then the 2B, the 2 was the class of fit. And remember, B was an internal thread because B is in the bottom. And A, we said, was around. So A is going to be an outside thread, so it would be a bolt. And a B would be an internal thread, like a nut. So you're going to have to be able to identify that. Now, speaking about the final exam, there is going to be some information on there on GD&T. I am not going to hold you accountable for those. So for those questions that are GD&T questions, you're just going to get credit for those. Okay, and we kind of barely just touch on those as it is. And I think there's only like one question that has like 4 questions, so it gives you a little symbol. What is, and you have to name like 5 things, but you don't even have to worry about those. So what you will have to do is you're going to take a drawing. You're going to have to draw an orthographic projection drawing. That's going where one of the views is going to be a full section, and you're going to have to dimension it. So I'm going to grade that based on your layout. Did you lay it out properly? Is your projection from the top, front, and right side, are those accurate? Do you have your section view? Do you have your are you hatched? Do you have your section labeled? Do you have your cutting plane laid? And then there's going to be your scale. Do you have your title block and your scale out properly? And then there's the overall, how does that drawing fit? So in the final exam, when we get to that, and I'm going to open up the final exam as soon as we're done with class. So you can take that final whenever you want. But the final is due. I'm just looking on my email here for my schedule. Launch this out here. So our final exam is scheduled for Monday, the 27th. So Monday, I'm going to give you till midnight on Monday to complete that final exam. Okay, so it's going to be open tomorrow, or actually open right after we're done recording here. I'm going to open up the final exam so you can start it whenever you want. Remember that the final exam is going to be limited to 150 minutes. So when you take the final exam, there's going to be a drawing portion, and then there's going to be the fill in the blank or multiple choice type question. Okay, when you do the drawing section within the test, there's going to be a place in there for you to submit your AutoCAD file. So you're going to submit your file, and then outside of the exam, there's going to be a place for you to plot your PDF of your drawing, so I can actually write on it, and that's where I can do my grading. Okay, so I'm just looking at it real quick here, just to make sure that I'm giving you all the appropriate information.
So once we open it up, it'll only give us 150 minutes to do it?
Correct. So I'm going to share that. You can't see this yet, but this is what it looks like. So you should be looking at my Blackboard, yes?
Yep.
Okay, so here's the final exam. So this is where you're going to select it. Once you select it, you're going to go into it. You're going to do your questions. And what you need to draw is also inside the final exam. So you'll get all that information from the final exam. Once you're done, then you're going to plot as a PDF. Inside the file, there's going to be a file submission where you're going to submit your DWG file in the test itself. And then the exam part 2, this is where you're going to submit your PDF so I can grade it. And then I get, just like I think we did on test number 1 or 2, then I'll go back in and grade in the test once I have your PDF on the outside so that I can mark those down. And that way, when you look back at your final, you can see where did I get, what points did I get, what did I get wrong, as opposed to just a score and have no idea what happened. Does that make sense? So I'm going to open this up as soon as we're done with the test. So I'm going to pop it open here. I'm just going to start it like I'm a student. And you're going to see that it says you have 2 hours and 30 minutes. So as soon as you hit begin, it starts. Okay. And then I also have it as an automatic submit. So at, 2 hours and 30 minutes or 2 hours and 30 minutes or 150 minutes total, at the end of that, it's automatically, boom, it's going to submit whatever you have. Okay. So everybody else typically gets 2 hours, which we give you in class. So to deal with internet and crashing issues, we're giving you an extra 30 minutes to finish that. The drawing, if I were to give you any advice, I would tell you to go through and answer all of the questions first. Just open the test, answer the questions, and then start your drawing. because that way you can get the easy points quick because they're just fill in the blank, multiple choice, true and false, and then start your drawing. And then once it submits, now I'm going to look at the timestamp because the PDF is not locked out to a 2.5 hour time frame. So I'm going to look at when did your test submit and when did your PDF submit. Will I give you some leeway? Sure. But if you submit your drawing or your test submits at 10 o'clock and then your PDF submits at midnight, I'm like, wait a minute, you just took 4 hours to draw this. That's not fair. Okay, so if you're off by a few minutes, I'm not worried about that. So that's kind of how that's going to work. All right. Does that answer everyone's questions?
So will the 27th be the final for all of our stuff as well?
Yes.
Needing it to be graded and submitted in?
Actually, all of your work, your daily work has to be in by Sunday. Okay, so on Monday, the only thing I'm going to be grading is final exam. So
the 26th, everything needs to be in.
Correct. So
Okay.
by Sunday at midnight's the cutoff for all of your weekly work.
Okay.
Okay.
Yep.
Anybody else got any questions, comments, concerns, worries, wonders? Again, I'm available with Zoom. I'm willing to help you out in any way, shape, or form that I can. Remember to fill out your surveys. You should have gotten those on Blackboard. I know on my Blackboard, when I get them, they're in the lower left-hand corner of my Blackboard when I open it up. I get a bunch of hate mail because I think there's only been 3 people who have submitted in all of my classes and all of their surveys. So if you would, please make sure you get those submitted. You have through Sunday to submit all of your weekly work. And then your final exams due Monday night by midnight. Again, if you decide to take and you're ready to do this on Thursday, feel free. Work at whatever leisure works for you. Okay? Any other questions, comments, concerns? Hey, you guys have done a fantastic job, making the switch from FaceTime to online. It's not easy. I'm teaching this class again online in the late summer. So there's a lot of things I've never taught EG110 online. There's a lot of things I got to do a lot differently. It's just because it's a different format and a different way to get you information. Speaking to Mr. Sterling, I don't know if you guys know Mr. Sterling. He also teaches EG110, and we were discussing today that there's, between the two of us, and we're just 2 of us that have done it, there's so many things that we have to learn about teaching some of these courses. So it's just different from face-to-face to online. So we've got some work to do too, and I think everybody's aware of all of the faults that happens when we go from FaceTime to online. But I really appreciate all of your efforts and your willingness to work with me. So I really appreciate that too. You guys have done a wonderful job. So let's finish it up strong, and we'll finish this up by next week. All right?
Yep.
All right. That's all I have for you. We'll see. Well, we'll hear from you soon. Good luck on your final, and I'll have grades posted as soon as I can get those out.
Thank you.
Thanks.
Take care, guys.
You as well.